Hello everyone, this is Cameron Snow and this is our first educational video for the Danomics Global Student Competition. So, because during the competition we are going to be, working extensively with well log data and learning about petrophysics and log analysis, I wanted to provide you with a little bit of background on the history of well logging, what well logs are, and then some of the subtleties that come into play with well log data. So, a little bit of the history of well logging. So, many of you have probably heard of the company Schlumberger. It's one of the largest service companies in the oil and gas industry. And this is because Schlumberger has a very long history. Conrad and Marcel Schlumberger logged the first, or ran the first commercial logging job back in the 1920s. This was a resistivity log. Then shortly thereafter, the SP log was developed in the 1930s. Gamma ray and neutron logs were developed in the late 30s. The induction resistivity log and micro logs and lateral logs came along in the 1940s. Then we got our sonic and density logs in the 1950s. PE logs came along in the 1960s, and it's been getting more and more sophisticated ever since then. So, well logging is something that's been around for almost 100 years now. And you may be asking yourself, what exactly is well logging or wireline logging? So well logging is after we drill an oil and gas well, we run tools down the hole, and these tools measure a number of properties. So like we just discussed about, it measures the resistivity of the rock and fluids in the well bore. It measures the naturally occurring radiation. It measures the things like the transit time from an acoustic wave being pushed into the formation. It measures the density of the rocks. And all of these measurements tell us about the properties of the rocks in the reservoir. So it tells us things about the porosity, the clay volume, the fluid saturations, whether or not there's oil or gas or water in a formation. So that is what we learn, the type of information we learn from well logs. You'll hear a lot of terms thrown about when it comes to talking about well logs. So you'll hear us talk about open hole logs. This is when we collect well log data from the uncased portion of a well. You'll hear us talk about cased hole logs. This is after we've ran casing in a well. It's still possible to run logs and collect data. And these are often similar but not identical pieces of data. So there's special interpretations that you'll perform for each of those. Earlier, I mentioned the term wireline logs. These are logs that are collected using an electrical cable that we use to lower tools down into the hole. These are often higher resolution measurements, and they're often considered better quality than the alternative, which are MWD or LWD logs, which are open hole logs that are collected during drilling by instruments that are located just behind the drill bit. So, if you're drilling a well and you want to get that real-time information, as you're going through the reservoir, which is often the case with offshore wells or exploration wells, you'll use the MWD logs. And then you'll hear some terms that are, less official, words like triple combo or quad combo, which often refer to the log suite that has been collected. For example, a triple combo is a combination of the gamma ray, the resistivity, and then the porosity tools like density and neutron. Quad combo is a triple combo with the sonic. And these are common terms that you'll hear people throw around in the industry. I would just encourage you not to get overwhelmed by all the terminology that you'll hear. It takes years and years to learn all the jargon and all the terminology. And even though, those of us that are in the industry, we use this jargon all the time, we don't expect you to know it. We expect you to learn it through experience. So one of the things when it comes to well logging is that we use a lot of mnemonics. There's somewhere between 20 and 30,000 tool mnemonics out there. and there's no comprehensive dictionary of references. Um, so often, for example, you hear about something like a gamma ray log. But then when you actually go in and you look at the well logs that have been ran, you'll see a number of different mnemonics such as GR, CGR, ECGR, GAPI, GRC, and all these are, a result of different vendors having slightly different tools and slightly different ways that they want to market this. Sometimes these are straightforward and easy to decipher, and sometimes, uh, you'll often be at a loss for, what a mnemonic actually is, and this is perfectly normal. There's really no comprehensive dictionary out there for them. And about 90% of the time, you'll be able to figure out what the well log is, but sometimes you just won't. And so that's okay. It's really about, being able to recognize what it is that you do know and being able to work with that. And you'll often see these change by vendor, by tool generation, by depth of investigation, and so on. So, try not to get overwhelmed by that. There are a number of ways that we try to handle this, and I'll go over some of those here in this video. When it comes to managing all these mnemonics, this is really one of the more challenging pieces when you're getting started in the industry, especially with a new piece of software. Um, and we use what are called alias tables for this. And so an alias table basically says, let's take all these various mnemonics. So let's take all these mnemonics in the case of gamma ray, and let's alias them all back to something we recognize, like the term gamma ray, GR. And this will allow your software to basically make it where you only have to see gamma ray as opposed to seeing the 50 different mnemonics. And when it comes to building out these alias tables, around 500 or so mnemonics will cover 75 to 80% of all the data that you'll see. Once you get up to around 1,000 mnemonics, this will cover 85 to 90% of all data. And it takes somewhere around 5 to 10,000 curve mnemonics in your alias table to cover 99% of all the available data. And then beyond that, you really start running into some very specialized, very rare data sets out there. So you really don't need to build out your alias table beyond, hopefully a few thousand aliases. Um, one thing that's important is as you're going through projects during your career, try to avoid creating your own mnemonics by unnecessarily duplicating curves or appending suffixes. This is a surefire way to just create bloat in your alias table and to make it harder to uh, manage some of these changes through time. Um, the other thing is avoid using what are called rush logs from service companies. Uh, a lot of times, your service companies like Schlumberger, Halliburton, Baker, they try to get you data as quickly as possible so you can start making the operational decisions that you need to make. But oftentimes these rush logs, they contain lots of curves that were never meant for day-to-day use. And this is done because it can often help get you the data faster, but it often means that you're getting curves that you were never meant to actually use because they're internal to the tools and they really just wouldn't mean much to you. And having these can really clutter your projects. So in terms of putting this to use, what does an alias table actually look like? So I am going to show you a little bit here from the Danomics software. So I am going to show you our alias table here. So we have around between 7,500 and 10,000 curve mnemonics aliased in here. And so, for example, here is an alias to the caliper curve. The caliper curve measures the diameter of the borehole. It tells you, information about, how has what's the shape of the well bore and how does that compare to the size of the well that was actually drilled. And so you'd think this is a fairly simple tool, but we can see here that there's roughly 100 different mnemonics that are common to the caliper curve. And some of this has to do with data that's been acquired via different vendors, or do we have calipers that measure only in one dimension, or do we have X and Y calipers? There are calipers that are higher resolution, there are differential calipers, etc. And so it just shows that even one of the most simple tools we can have an extreme number of mnemonics for. And so that's an example of how we take hundreds of different curve names and we alias them back to one curve name. And this is something that's common across almost every mapping package in the oil and gas industry. I just want to highlight a couple of other situations here. So let's look at the gamma ray curve, for example. Here we see things like GR, CGR, ECGR, so common mnemonics. We also see things here like GR underscore neutron or GR underscore LWD. And what this is telling us is it's saying, hey, this is the gamma ray that was on the neutron tool. Here's a gamma ray that was ran while performing logging while drilling, or gamma ray with measurement while drilling, which are really the same thing, but different vendors use different terminologies once again. And so you'll often have multiple sources of the of each log curve. So the gamma ray is often used to correlate tools together. So you have a gamma ray tool, you have the gamma ray on a neutron tool, you have a gamma ray on a sonic tool, for example. And so this is how you can have multiple curves of the same type in the same well. Okay, so we've talked a lot about curve mnemonics and where these come from, but let's actually take a look at at what a well log looks like. So well logs come in the form of LAS files. So an LAS file stands for Log ASCII Standard, which was defined by the Canadian Society of Well Log Analysts. And almost all well logs look somewhat the same if you open this file up. So it'll start off, each well log will have some version information, which will tell you is it the 1.2, 2.0, or 3.0 format. Are the digits wrapped, or are they allowed to go on the same line? And who the vendor is. You'll have a well section that'll contain information about the start depth, stop depth, and the step. The step being, what the depth increment is. It'll tell you what the null value is for a well. Hopefully it'll have an API or UWI number. What was the company that drilled the well? What's the well name? What's the field, the county, the state that it was in, the country, when was it logged? And then you'll have the curve information section, which corresponds to what curves are located in this. So generally we have the depth curve first, and then after that you'll have a number of curves. And here we can see we have a density porosity, a neutron porosity, density correction, a bulk density, which is essentially just an uninterpreted version of the density porosity, gamma ray, caliper, sonic, then our resistivity suite, and then even in this one we have a second gamma ray in here. So we have a lot of different information within this well log. And then essentially we just have several thousand rows of values that correspond to the depths at which this well was logged. Often you will have multiple well logs per well, so you'll either have different tool runs. So maybe you run your gamma ray plus your resistivity and your neutron and density tools in one run, and your sonic in a separate run. Or you log the shallow portion of the hole, you run casing, and then you drill the deeper portion of the hole. And so you may have multiple LAS files for each well. So LAS files, even though they are quite simple to look at and to read, they, you know, can present a number of complex challenges due to the number of logging runs for a well and the variety of data that sits within that LAS file. So that is just a brief overview of well log data. We're going to be going into how we interpret this data in subsequent videos, but I hope this is useful to you, and I hope it gave you a brief introduction to well logs. If you have any questions, please comment on the video, and I will answer those there. Thank you very much, and good luck in our student competition.